I tested the new LLaMA for Scout on 5 different providers with the same prompt, and the results are really surprising. There are multiple different API providers hosting the same LLaMA 4 models at different price points. But the question is, do they provide the same level of performance, or there's something else going on? So I decided to use the same prompt on 5 different providers. We're going to be using the official Meta hosting, OpenRouter, Grok, Together AI, and Fireworks. So here's the prompt that I used. It's a variation of the ball bouncing within a hexagon, but it's a lot more complex. So write an HTML program that shows 20 balls bouncing inside a spinning heptagon. All of them should have the same radius. They should be numbered from 1 to 20, and all of them should drop from the center of the heptagon with these specific colors. They should be under the effect of gravity and friction and must bounce off the rotating walls realistically. And also, none of them should exceed the radius of the heptagon when they're bouncing off, but should always be higher than the ball radius. And this is talking about the bounce height. They should rotate with friction. The numbers on the ball can be used to indicate the spin of the ball. And then the heptagon is spinning around its center. The spinning speed is spinning 60 degrees per 5 seconds. The heptagon size should be large enough to contain all the balls. And I asked all of these providers to put them into a single HTML file. A couple of other conditions. First, I'm going to be only testing the LLaMA 4 Scout. And the reason is that not all of the inference providers that I chose have the Maverick version available. So for example, Grok is currently only hosting LLaMA 4 Scout. Second, where available, I'm going to set the temperature to 0. The output length is going to be at least 4,000 tokens. Grok currently only provides 8,000 tokens output, so it kind of limits the usability. Okay, so we're going to run the same prompt. We will also compare the speed of generation, also the quality of output. For Meta AI, I don't know whether they are hosting Maverick or Scout because it's really hard to tell. However, Meta AI has one serious problem, and that is the maximum number of tokens it can generate. So it says Meta AI has reached its word limit for this prompt. To continue, try a more specific prompt. So I asked it to just continue completing the code, and it gave me the complete code. Okay, so the moment of truth. We're going to run this. All right. Okay, that was pretty bad. So it started in the center, which is good, and this actually is a heptagon. However, as soon as it touches one of the sides, it stops. Okay, so I told it when the ball drops and touches the side, the heptagon stops rotation. So it gave me an updated code. Okay, so we updated the code and let's see what happens. Okay. Oh, no, didn't work. Next, we're going to try the same prompt on OpenRouter. So I'm using a free LLaMA 4 Scout that is available. There are a number of different providers that you can choose from on OpenRouter. Now, OpenRouter does not give you the ability to set some of the hyperparameters like temperature or custom instructions or system prompt, as far as I can tell. So we're going to just rely on the default system prompt and the default hyperparameters. Now the speed of generation seems to be pretty decent on OpenRouter as well. Okay, so this gives us about 66 tokens per second. It generated a total of 3,300 tokens. But something really interesting happened on OpenRouter. So it started implementing the code, and once it provided me with the initial version, then it says, however, to provide a better structured code, here is an improved version. So seems like the model has some sort of reasoning capabilities. I'm not sure, but it gave me 2 different versions of the code. So we're going to start off with the improved version and see what the output looks like. Okay, so we're going to come here. I'll paste the code. Let's run this. Okay, this is really interesting. So it wasn't able to draw the heptagon correctly. There seems to be 20 different balls, and the initial condition has been met. It is actually dropping from the center. But after that, I'm not really seeing any realistic movements. The balls are just staying at the same point and the heptagon is rotating. I also want to try the original version before making the optimization. So we're going to replace this code. Let's run that. And that does not work at all. Okay, next up is going to be Grok, which is going to be extremely fast. So I'm going to set the temperature to 0. We'll keep the maximum completion tokens to about 7,000, which should be more than enough. There's no custom system prompt. And let's send this. And let's wait for the generation. You can see it's generating 500 tokens per second, which is kind of crazy fast, right? And it took about 3 seconds to generate the output. You don't even see how the output was generated. All right, so we're going to copy this code and let's see what the output looks like. Now, as far as I know, all of these providers are hosting the model in 8-bit floating point precision. Okay, so let's paste this, let's run it. And the same issue. So it started off from the middle, drops off, touches a side, and then it stops rotating. Again, we have a heptagon, so it followed the initial instructions. Okay, so I asked it to fix it. It gave me the updated code. This time, again, it's about 500 tokens per second. Crazy fast. However, even with this updated code, we are running into exactly the same issue. Okay, next we need to talk about Together AI. So with the same prompt, it gave me a code that I'm going to run. But after that, it kept going. So for example, here it talks about how the code works. And then it say, have fun with your bouncing balls. Best regards. Hope you like it. Let me know. Cheers. Thanks. Bye. See you. Have a great day. Enjoy. Right? And it goes on and on and on and on and just starts saying best, cheers, thanks, best, cheers, thanks. Right? So this seems to be a little bit of drunk. And this is giving us 100 tokens per second. And I think it generated about 8,000 tokens. So we're going to copy the code that it generated. We're going to run it. And yeah, this is kind of crazy what it's doing. First of all, the heptagon, it doesn't seem to be right. Then I think it's generating multiple versions of the balls as well. Now I do want to run this one more time. So we're going to set the temperature to 0. Output length is going to be set to auto. And there's no system prompt. So let's run this one more time and let's see what output we actually get this time. I think some of the issues that we might be seeing might have to do with the configurations, because mostly when these open weight models are released, the configurations are not right. And Together I again got drunk and started generating those random tokens. Pretty bad look. Now, it does offer a lot other settings, for example, sampling hyperparameters, but I'm not touching any one of these. We're going to keep everything to the default, apart from the temperature, and even output length in this case is auto. Okay, so I pasted the code. Let's run it one more time. And we see exactly the same issue with Together AI again. Okay, the last one is going to be Fireworks AI. Now, in this case, I ran exactly the same prompt. We're going to copy the code that it generated, and let's see what the output looks like. Okay, so we paste the code, and yep, it's exactly the same issue that we saw with some of the providers. It starts off nicely from the middle, but then as soon as it hits one of the sides, it stops rotating. Okay, so I told it about the issue. It gave me the updated code, and the updated code is running into exactly the same problem. Well, that was new because it just disappeared. So a couple of things. It seems like there are probably some differences between the different versions of the same model that are being hosted. I'm not talking about in terms of the weights, but how they're being hosted by different API providers. My understanding is that all of them are hosting it in 8 bits. But let's try the bigger Maverick model on some of these providers and see how it behaves with the exact same prompt. And before testing Maverick, here's what the output looks like using Claude Sonnet 3.7 without thinking. So if I start this off, it actually falls down, and then everything seems to be following all the instructions that we had. There are no bouncing of the balls, but that is because of the friction. And you can see each of the ball is rotating whenever it's colliding with other balls. So this is the kind of output we would expect. So now our options are limited. I'm not going to try Meta AI because we already saw the output. Grok currently is not hosting the bigger Maverick model. The only option that now we have is Together AI, OpenRouter, and Fireworks. So we're going to start with OpenRouter. I'm going to paste the exact same prompt again. Let's send the prompt. Let's see what the token generation speed looks like for this bigger model, and also the quality of output. Okay, so we're getting about 60 tokens per second, a total of almost 2000 tokens. Now let's see what Maverick did with this code. Okay, much better actually. Let me run this again. So one thing is it started right in the center, but rather than falling down, it basically exploded. I think it still kind of makes sense. And then seems like they are following the original prompt pretty good. I would expect a lot more rotation, but it does seem to be working to an extent. So not bad at all. Now I feel like the bar is going to be pretty high for these other providers. So again, we're going to be testing Maverick instruct. Output length is going to be auto. Temperature is set to 0. And this next one is Together AI. So let's send the prompt and let's see what happens. I'm curious to see if it has the same repetition problem as before. So far, so good. Now, Together AI is definitely doing much better in terms of tokens per second. It also produced about 2000 tokens. So the output seems pretty consistent in terms of number of tokens. One more thing, we could actually change the repetition penalty, and that could have an impact on the repetition issue that we saw with LLaMA for Scout on Together AI, but I wanted to keep everything to the default to have a fair comparison of different API providers. Okay, so here we're going to run the same prompt again. It's not doing as good. Oh, okay, so it drops from the middle, and then in the last turn we saw that it just falls off. All of the balls fall off of the heptagon. Really bad look here. Okay, next up we're going to try Fireworks AI, and let's see what type of fireworks we actually get. So if it doesn't run into the repetition issue, I'll probably try these parameters with Together AI and see what happens. So still, speed of generation is pretty good. I think it is generating at 123 tokens per second. So Fireworks AI seems to be the second best when it comes to tokens per second, second to Grok. But since Grok is not hosting Maverick, so for Maverick, this seems to be the fastest among the API providers that we have tested so far. But speed is not the only thing, it has to work. So I copied the code. Let's run this. And okay, this is weird. The balls are falling down, but very, very slowly. And I'm curious what happens. No, as soon as they touches one of the sides, it simply stops. So I also want to try Together AI with the same hyperparameters as Fireworks AI. So I ran this and let's see what the output looks like. Okay, so let's run the code. And no, yeah, I think it's running into exactly the same issue. So it starts off nicely, but then the balls just keeps dropping and dropping. They go out of the frame. Okay, so a couple of things that I wanted to figure out in this video. As I said in the beginning, there are multiple different providers hosting the exact same model or same weights. They are offering different output speeds depending on the hardware at different price points. However, there definitely seems to be some differences when you're using the same model on different inference providers. So if you're trying to use one of these inference providers, make sure to test multiple of them on your prompts and pick the one that seems to be doing better on your specific prompt. And that's why I wanted to keep a single prompt and see how all of these inference providers generate the output based on the same hyperparameter in cases where I could control them. A second is this plot that I want to discuss. So we have independent benchmarking of a LLaMA 4 series. So here, based on the average score on the 7 different evaluation or benchmarks, LLaMA 4 Maverick seems to be the third best model for non-reasoning models. LLaMA 4 Scout is on the 12th position. Now, this is based on the overall scores, so not specific to one benchmark. But when it comes to the overall intelligence, and again, this is measured by the artificial intelligence team on their own intelligence metric, it's not as great as DeepSeek R1 or even QWQ, which is a 32 billion parameter model. Some would argue that it's only 17 billion active parameter models, since both the Maverick and Scouts are MOEs or mixture of experts. However, the actual size of the models are much larger compared to something like 32 billion. You definitely want to have your independent benchmarks. I'm going to be releasing another video specifically testing the coding capabilities. However, if you're looking at the academic benchmarks, it's important to look at individual benchmarks as well, because right now this is on the 3rd position overall. But if you start looking at independent benchmarks, you start seeing a very different picture. So, for example, if you look at the humanities last exam for non-reasoning models, the LLaMA 3.18 billion model is on the 3rd position. Maverick is on the 5th position. So you really need to understand what exactly these benchmarks are measuring, and then based on your specific application, you can choose a model. Right? Now there are 3 different benchmarks for coding. One is Live Code Bench. This is the one that Meta highlighted in their blog post. So here it's on the 4th position behind GPT-4o, DeepSeek V3, and Claude 3.5 Sonnet. If you look at Scicoding, which is another coding benchmark, this is again on 4th position. But if we look at Human Eval, which is another coding benchmark, then it drops down to 7th position. So again, it's very critical to analyze all of these benchmarks holistically and don't rely on a single benchmark, even in the same domain. There's going to be another video in which I'm going to do my own testing. So if you're interested in that, make sure you subscribe to the channel and push that bell notification button. One last thing, the context window. So Maverick has a context window of 1 million tokens. LLaMA 4 Scout is supposed to have a context window of 10 million token. However, the question is there even an API provider or infra provider who are actually hosting these models to such huge context windows? So I think we have a lot more clarity now. So this is LLaMA 4 Scout on OpenRouter. OpenRouter basically looks at different providers and enable you to use them. So right now there are 6 different providers on OpenRouter for paid version of LLaMA 4 Scout. And you can see each one of them are hosting this at different max output length and even the max context as well. So most of it is 131,000 tokens. Parasail is providing 172,000 tokens, and that's probably also the max output tokens that they are providing. Deep Infra is limiting it to only 4,000 tokens, at least on the OpenRouter. Grok is another one that is limiting it to only 8,000 tokens. So if you're going to decide to use an infra provider, make sure you look at the max context window that they support. For example, for a coding task, 4,000 tokens is not going to be enough in the output. We are talking about a model that is supposed to have a max context window of 10 million tokens. Now for Maverick, the options are much better. So if you look here, Deep Infra is providing 131,000 tokens in its output. That's the max you can have. Some of these other providers are providing up to 1 million output tokens, which is really good. And I think for anything serious, people are going to be mostly using Maverick rather than the LLaMA 4 Scout. So just to recap, if you are going to select API inference provider for the LLaMA 4 series, make sure you test multiple of them based on your own benchmark dataset. look at the max context window and even the max output tokens that they provide, and also different price points and speeds. And one last thing, OpenRouter also provides a free version through this provider, which has, I think, a much better context window compared to some of the paid options, although this is going to be rate limited. And interestingly enough, it is actually hosting it in 16-bit precision. Now, for Maverick, again, we have the free option to the same provider, and this time it's limited to 256,000 tokens, which is still pretty good. But now it's hosted in 8-bit, which is probably most of the API inference providers are using. Anyways, this was a quick video on comparing different providers on the same prompt. Let me know which one you prefer, which one you're using, and what type of performance you're getting with LLaMA 4 based on your own benchmarks. Again, if you're interested in the testing video that is going to be coming up pretty soon, make sure to subscribe to the channel. I hope you found this video useful. Thanks for watching, and as always, see you in the next one.